Hi, what's up guys? This is the Econ 3410 video for homework 8.2.17. The scenario that has been given is the consumer organization wants to estimate the actual tread wear index of a brand name of tires that claims graded 150 on the sidewall of the tire. A random sample of n equals to 16 indicates a sample mean tread wear index of 148.3 and a sample standard deviation of 28.4. So before we move on to the questions, the distribution we're going to use here is a t-distribution with sigma unknown. And the equations we use here is x bar, which is the sample mean plus or minus t half of alpha, with alpha here is the significance level multiplied by s, which is the sample standard deviation divided by square root of n. So n here is the sample size. And in order to get the lower limit and upper limit of confidence interval, we need to use this inequality here. For example, if we have a 95% confidence interval, alpha here is 1 minus 95%, which is 5%. So half of alpha is 2.5%. If we look up at the t-distribution table, we want to take a look at the 0.975 cumulative probabilities of that distribution with a degree of freedom of n-1. For question part A, assuming that the population of tread wear indexes is normally distributed, construct a 95% confidence interval estimate of the population mean tread wear index for tires produced by this manufacturer under this brand name. The data has been given is, we know the sample standard deviation is 28.4 and the sample mean is 148.3. The sample size is 16 and the confidence level is 95%. Then we move on to the intermediate calculations. First of all, we'll calculate the standard error of the mean, which we use the sample standard deviation divided by the square root of sample size, which gave us 7.1. And on the right hand side is the built-in function that we use to calculate this result. The next one, the degree of freedom, we use the sample size minus 1, which is 15. And for the t-value, we use the built-in function of the Excel, which is t.inv.2t. In the parentheses, we have 1 minus the confidence level, comma, and the degree of freedom, which is 15 here, and give us this answer here. So for the last one, we'll calculate the interval half width, which we use the t-value multiplied by the standard error of the mean and give us this 15.13. So please pay attention that there's also another built-in function can get us exactly the same result, which is confidence.t. In the parentheses, we have 1 minus the confidence level, comma, the sample standard deviation, comma, and the sample size. So next we move on to the confidence level. So for the lower limit of the interval, we use the sample mean, which is 148.3, minus this half-width interval and get this 133.16. And for the upper limit, we use the sample mean plus this half-width interval and get this upper limit. So another thing we need to pay attention to is for the t-distribution, the higher the degree of freedom, the more closer it is to the standard normal distribution. And that is for part A. For part B, do you think that the consumer organization should accuse the manufacturer of producing tires that do not meet the performance information on the sidewall of the tire? Explain. So since we have the interval that is something between 133 and 163, 150 is actually in this interval, so that we cannot accuse the manufacturer of producing tires that do not meet the performance information. So the answer should be A. And for part C, explain why an observed tread index of 165 for a particular tire is not unusual, even though it is outside the confidence interval developed in A. So we can see that this 165 is actually beyond this confidence interval. And let's take a look at different choices. For part A, it is not unusual because it's actually in the confidence interval, which is not true. And for part B, it is not unusual because it is only 0.59 standard deviations above the sample mean. So we can do a quick calculation here to check whether it is true or false. So we use the 165 minus the sample mean, which is 148.3, divided by the sample standard deviation, which is 28.4, which gets us 0.58, which can be rounded to 0.59, and this is the correct answer. So since choice B is correct, choice C is not correct. And for choice D, it is not on euro because it is just outside the confidence interval. So the interpretation for the confidence interval is that if we used up all the samples and 95% of the intervals developed would include the population mean somewhere within the interval. So we cannot really say that just one index outside the interval is on euro or not. And that is the end for this part.